the transfer function for me?
Yes.
Yeah, let me put
How
this
do
up.
you do that with J?
Okay. The plotting is less difficult than you might think.
Thanks.
Because I have given you, this is NQ2, problem 1D. I have given you a drawing here with these, plots all over. So it's very easy to find points in this complex plane, right? It's relatively easy because it's like a piece of graph paper. The dark lines here are 0 and 0. So those are the axes.
Is the horizontal slices, are those P?
This is, no,
I thought that was J.
no, those are J. Yeah. Those are imaginary.
Okay.
So what we can do now is take a look at this transfer function. P of S is equal to 5S plus 2 over S plus 3 cubed. And now we have to do that in terms of omega.
It's S plus 1 cubed.
S plus 1 cubed. Saw 3 in there, by gosh. So 5j omega plus 2. And just because of the way we're used to putting numbers in our calculator, I'm going to put that the other way around. Does that change anything?
No.
And then 1 plus j omega, 1 plus j omega, 1 plus j omega. Can you put that in your calculator with omega as an unknown or a variable?
Sure.
Yeah.
Probably.
If you can, then literally all you do is put in different values of omega and get out of this a real number plus an imaginary number.
Okay, that makes much
That's the
sense.
real number, that's the imaginary number. And it's going to go the other way. Real, imaginary. So real, imaginary. And there's your plot point.
Thank you, that makes much more sense.
Because it plots just like rectangular coordinates. So we talk about the Nyquist as being a polar Bode plot, kind of, but for this, it's literally just x and y, x and y. And I'm not going to give you a problem like that on a test. I'm not going to give you a drawing. I'm most likely going to give you a drawing, and not a drawing you have to make, but give you a drawing and ask you questions about it. I have once, I think in the past, asked you to draw a Nyquist plot with certain characteristics, and you can make whatever squigglies you made that actually have those characteristics. Okay, it's not as hard as it looks at first, because you want to think in terms of angles and distances, and it's just, oh, it's much easier just to do it in rectangular coordinates, because that's the plot we've got there. You've got the rectangular grid marks. All right, other questions? Does that answer your question from NQ2, Mr. Rubin?
It's like
Moral. Yes.
Yeah, no question. Wait, what?
Or do you want a question?
I did have a question about NQ2.
You weren't fast enough.
Problem 4. But I mean, hey,
What's that?
I just had a question about NQ2 problem 4. It says repeat it for 3 of cosine of t and 4
Number
of
4.
cosine.
Oh, on the
Oh, let's see. Repeat part B for the system for the code. Oh, okay. Do you understand how to get the numbers for part D?
Not entirely.
No? Okay. I need that drawing,
Okay.
because otherwise I cannot do this. And you're going to have a hard time doing this without drawing. We're doing. So remember those problems on the Bode plot homework where you had to take some numbers off the Bode plot, a magnitude and a phase. Recall that? And from that magnitude and phase, you can figure things out about the G of S at that given omega. So we have this funky Bode plot. Nyquist plot. It starts at -2. I could not imagine what
mean,
actually
two, right?
Here, omega was equal to 1, and this was at -j. Then it went to 1/2, or -1/2, where omega was equal to 5. Then it does this And this is not to scale, okay? I can't draw it to scale. I'm happy I can even draw it. 1/3 doesn't tell you what omega is in that point. Comes back 1/4 and finally does something like this. So that's what it is, -1/4. Okay. So, let me ask you this. Any of the rest of this give you any trouble?
The rest of the homework?
No, the rest of this problem. Should we look through the whole problem?
I'm okay with looking through the whole problem.
Yeah.
Okay.
Yeah.
We'll just make Mr. Morrill wait.
What's up? Help me draw one, Arn.
Okay,
That's all.
knowing that the closed loop system is stable, can one say for sure that the open loop system is stable?
What?
So, if you, this is problem 4, NQ2 problem 4. This is lifted straight out of an old final. A. Knowing the closed loop system is stable, where's -1 by the way in this drawing? Good choice.
Yep.
Knowing that the closed loop system is stable, can one say for sure the open loop system is stable? What letter do you get out of this whole Z = N plus P when someone tells you that the closed loop system is stable?
Z is 0.
Z is equal to 0. That's exactly what you should get.
Closed loop is stable.
Z is equal to 0. If I look at this, what are the encirclements? 0. Plus, what does P have to be?
P is 0.
0. So, can you say for sure that the open loop is stable?
Yes.
Yes, because P has to be 0 for that equation to work. Given the closed loop system is stable, estimate the gain margin and phase margin of the closed loop system. So, first, how much bigger can I make this before I run into problems? Twice as big. It's an easy number to see. So, what's the gain margin, Jim? Yeah. So gain margin is 2. 2 is where we run into
I've
problems.
heard it's easy.
So the gain has to be less than 2. If you want to put K is less than 2, that's also okay. I understand that. But the gain margin would be 2. Notice we don't say it in terms of dB now. Just do it in terms of absolute numbers. C. How many unstable poles does the closed loop system have if the open loop gain is multiplied by 5? So we make it 5. I'm going to come back to that in a second. We make it 5 times bigger. So where does my -1 go now? If I made it 4 times bigger, would this cross over the -1 point?
I'm confused. Where is it at now?
Do you have the homework problem?
So like you said times by 5, but is
Yeah. So we boosted it by 5. So where is -1 now?
Oh, we can think of it. This is what you mean by like shrinking the scaling. Okay.
Yeah. So my -1 would be there now, right? Because the 1/4 would actually be 1.25. We're multiplied by 5. So we can count the encirclements there without redrawing the drawing. How many encirclements do I get? 4. 1, 2, 3, 4. So how many closed loop unstable poles are there? 4.
There's a part B, the phase margin, so.
Oh, did I not do the phase margin? Okay, phase margin. Now, you have to think of a unit circle here, but there's nothing to help you guide you drawing a unit circle, or is there?
Yeah, exactly.
Unit circle.
Yeah, that exactly.
Do I know where it changes, where it crosses over?
Yes.
So what is the phase margin?
90.
Yeah. So notice this drawing, this thing is, if you know the basics about Nyquist plots, everything comes out really easy on this. But if you don't, you can't answer the questions. Let's see.
Would you ever ask a question where you're like, at what gain margin would your phase margin equal this? Or-
Too hard to do.
Okay.
Too hard to do unless I can come up with some way where you can easily see it. And I guess I could come up with it on the polar plot, but
We don't
it's
want to.
really difficult because the way it expands is kind of hard to see.
Yeah, I don't get ideas.
Yeah.
But if you think about shrinking the units, that's the really thing is. So if for instance, if the gain were 2, you could figure out a new phase margin because you just draw, instead of a unit circle, you draw a circle where? At, not 2, 1/2. 1/2.
Oh, it'd be-
1/2. Yeah. So that sort of question is doable. But the opposite of that question is much harder. Let's see, given it's actually not that bad. Because you draw your angle,
As long as
you draw your angle and then you figure out where that crosses, you draw an arc back to the real plane and you can say what to, yeah, you can do it. But I haven't talked about it, so maybe next time.
Hopefully not, next time it's not the final.
No, next time, next year. I can put a problem like that on the homework, then I can feel comfortable doing it in the test. Let's see. Given the steady state response of the open loop system to an input of x2. So x of t is equal to 2, that's 2 times the unit step function, and what's the frequency?
0.
0. So what's the gain of the system at omega equals 0?
Means
2. So 2 times 2 is 4, yeah, that's all you have to do.
Wait, say that again?
Yeah, you kind of lost
Yeah,
me.
you lost
Yeah,
me.
you lost me there.
2 times 0 is
You-
not
you were-
2.
What is it, 1 times 2? 2 times 2 is 2. Or 4. Can you?
2 plus 0 is 2.
What's the DC gain of this system?
2.
Oh, that's when omega equals 0.
Yes.
So since this is a
Oh.
DC input and we know the DC gain, Ruben!
Well, I guess we'll get to it, but all we're doing if we're putting in sinusoids is changing the phase angle.
Well, let's see what we can figure out. Repeat this for x of t is equal to 3 cosine t. So what is omega for 3 cosine t?
1.
Omega is a 1. Is that labeled on the graph?
Yes.
Omega is a 1. So what is the transfer function then? Well, P of S, P of J1 is equal to minus J, literally. Or alternatively, 1 at an angle of negative 90 degrees.
But there's a 3 in front of the cosines.
3.
Right, but I'm talking about the transfer function. So in order to get the output, we have to multiply the phasor of the input by that transfer function. What's the phasor of that input?
3 angle 0 degrees.
3 angle 0 degrees. So the output is
3 angle negative 90.
3 times 1 for the magnitude, and add the angles. 0 angle plus negative 90 degree angle. And for 4 cosine 5t is 5, omega equals 5 labeled on the drawing. Now those things are really hard to get off any real Nyquist plots because they're never labeled like that.
Thanks for labeling.
Yes.
So yeah, you're welcome. See, I'm not as bad as I look.
Makes so much help.
All right, so what's the angle and the magnitude at omega equals 5? Magnitude first.
Negative 1/2 or 1/2.
1/2.
Yes, that gives the
1/2. So 4 times 1/2 equals? So it's 2 cosine 5t plus or minus what angle?
180.
Minus 180. Yeah.
Does the sign matter? It doesn't matter, right?
In that case, it doesn't matter, but I would be expecting a minus 180 because of the way we got there.
No, sorry, the magnitude doesn't. It's just
No. That the phase angle takes care of the sign. So you're talking about a magnitude and an angle.
Oh, I'm
For a
just saying,
phasor.
like, the point at omega 5 is negative 1/2.
Yes. So you could literally say it's minus 2 cosine 5t and leave the phase angle off. That is mathematically the same thing. What I was expecting was 2 cosine 5t minus 180 degrees. And that's probably the answer that you've got. Yep. Nope. Where the hell is the answer?
No answers here.
Problem 4.
Probably not.
Oh, I gave you the minus 2 cosine 5t. Okay, the one I wasn't expecting I was going to give you.
Wait, I'm so confused. What's going on?
I was looking at the answer for part 4D, the third one. In 4D. So now, I have to repeat this